In this problem, we're going to do sort of the opposite of what we've done in the other ones in terms of the area and the values, and we're going to see the use of inverse norm on our calculator. So example 7 says, according to the Health and Nutrition Examination Study of 1976 to 1980, the heights in inches of adult men age 18 to 24 are normal with a mean of 70, standard deviation of 2.8 in inches. How tall must a man be? I think I left a word out here. How tall must a man be to be in the lower 10% for men aged 18 to 24? So what height would put you in the lower 10%, or in other words, where there would just be the area below would be 10%. Here, the 10% is the area, and we want to find the value that goes with it. So here's the picture. Okay, we have a standard normal distribution centered at 70, and there's some value, some x value that we don't know, to where the area over here would be 10% or 0.10. That's what the question's asking. What height would put you on the distribution to where the area below is 10%, where you're at or below the 10th percentile is another thing that they call that sometimes. Inverse norm will give you that value. Okay? Inverse norm is set up to where if you give it the area to the left, like in the tables, and the mean and the standard deviation, it will tell you this x value. Let's do it first with the table, though. So on part A here, we're thinking we need some x value, and I used a capital X to distinguish it from the little x here, but we want to find this x such that the probability that we're less than x in our regular distribution is 10%, 0.1. If I use tables, I have to use z-scores. We'll start by finding the z that has 10% below it. And what I would do there, I would just have to look at the table and look at the areas, which are the numbers inside the table, and find the one that's as close to 10% as I can get. And you're not going to get right on. We get 0.1020 and 0.1003. So the closest we're going to get would be right here, which would be negative 1.2. I had to cut it off to make it fit. Let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8. So negative 1.28 would be the closest value in the table to getting 10% for its number. Okay, so the closest z-score would be negative 1.28. So according to my table, if I'm at negative 1.28, that's as close as I can get to having the area to the left be 10%. Then you would have to convert back to x. Okay, so we have our formula that the z-score is equal to x minus mu over sigma, and we can fill in everything but x and solve for x. So negative 1.28, the z-score would be equal to x minus 70 over 2.8. Multiply both sides by 2.8 and add 70, and you get 66.4 inches. Okay. So it's possible to look in the z-table first and find 10%, find the z-score that puts you at 10% or as close as you can get to that, and then you can convert that back to an x value in the regular distribution. Here's how we can do it with the calculator. So in the calculator, we do second variables, and we choose number 3, inverse norm. And just like normal CDF, some of you will get this menu, some of you won't. You put these numbers in order if you don't get this menu, but the first value we enter is the area to the left. The Texas Instruments calculator is set up to where it has to be the area to the left. If you know the area to the right, you're going to have to subtract from 1 to figure out the area on the left. Like in this picture, we have 90% above it, 10% below it. We have to put the 10%. It has to be the area to the left. And then you give the mean and the standard deviation, which would be 70 and 2.8. And I can paste that on the screen. And again, if you didn't get the menu, you'll just see inverse norm and then parentheses, and you type those numbers, the area to the left, comma, the mean, comma, standard deviation. Hit enter, we got 66.4. 66.4. So 66.4 inches would give us 10% to the left, or that's the value that if you were 66.4 inches tall, your height would be greater than or equal to no more than 10%. You're at the 10th percentile, 10% below you, 90% above you. Okay, here's another example of that. So in designing motorcycle helmets, the engineers must consider the breadths of male heads. The head breadths are normally distributed with a mean of 6 inches, standard deviation of 1 inch. What percent of men have head breadths exceeding 6.5 inches? That's going to be a normal CDF problem because we're given the value and we need to find the percent. B and C, we're given the percents. Those are inverse norm problems. If the engineers are not concerned about the smallest 10%, what's the minimum head breadth they plan to fit? And if they're going to ignore the largest 15%, what's the maximum head breadth they plan to fit? Okay. So first of all, part A is going to be a normal CDF problem. We're looking for the area. We've got this distribution centered at 6, standard deviation of 1, so 6.5 would be somewhere like that. And we want to know what percent exceeds 6.5, so we would have the area above it, to the right of it in the picture. And I'm just going to use the calculator on these. So the probability that x is greater than 6.5 would be normal CDF, 6.5 off to infinity, 1e99, with the mean and standard deviation. Here, I'll punch it in the calculator for you. Second distribution, number 2. So we want to go from 6.5, it's a greater than, 6.5 to infinity, so 1e99. And then the mean and the standard deviation, 6 and 1. And we get it asked for a percent, about 31%, 0.3085. Okay, 0.3085 or about 31%. Okay, part B. This was basically the same question as the previous example. We want the value where there's 10% below, 90% above. Okay, what would x value would put you there? So that would be the inverse norm, the area to the left, 0.1, and then the mean and standard deviation. And you can punch that in the calculator. You should get 4.72 inches. Part C says the engineers plan to ignore the largest 15%. So we need to find the x value where there's 15% above it. But my calculator, I have to give it the area to the left. So if I do 1 minus 15%, they'd be 85% below. Okay? So it's very important on the calculator I give it the area to the left. So I would do inverse norm with 0.85, the area to the left, and then 6.1, and you get about 7 inches, 7.04 inches.